So today let us see how to use CopperCam software for PCB fabrication. So before starting the fabrication process, you have to get the necessary Gcodes, that is the machine language files to control the tool path. So that will be created using the CopperCam software. So what we need in CopperCam software is a gerber file. So let me take an example. I am using ECEDA to create my PCB. So here I have a schematic and I have already created a PCB file in ECEDA. Now let me export my so this is just a few 1 2 3 4 connections in the bottom layer. I have drawn the circuit in the bottom layer. Now let me export this. First step is to export your PCB fabrication file, that is the gerber file. So I'm going to generate my gerber file. So that has been downloaded as a zip file. So I'm going to extract here. So this is my gerber file for creating the PCB. So you can see that there are drill files, outline layer files, bottom layer, top layer, all those informations are there. Now let us input these files into our CopperCam software. So first step is to click File, Open. I'm going to import different layers. So first layer will be my circuit, that is the track. So File, Open, New Circuit. So in downloads I have my PCB. So I have drawn actually the circuit in the bottom layer. So if you have drawn in the top layer, you have to import this. Since I have drawn in the bottom layer, I am opening the bottom layer. So here you can see that my tracks has been imported. Now you can see that the drills are missing, drill files are missing in this. These are just the pad only, pad and tracks. So next thing is to import the drill file. So you can import it, open drills. So once you click on that, go to your same folder where here you can see your drill files. So this is the .drl extension is the drill file. Here is another .drl extension, but that is vias. So in my circuit I am not having any vias, I am having only some holes. So I am going to open that. So system will automatically align with the pads. So it is perfectly aligned. So system is asking me a confirmation regarding that. So is this file import valid? Since it is valid file, I can click yes. If it is not valid, you can click no and you can align it yourselves. Okay. So it's already automatically aligned. So next thing what I have to import is actually the outline. So File, Open, Additional Layers. Go to Additional Layers. There you can see the gerber border outline layer. So if this is not visible at any time, you can click all files and make it visible. So it's already visible in my PC right now. So click Open. So this is actually the outline. Now the PC is asking me whether the highlighted track is the boundary or not. Sometimes PC may misidentify some other tracks as the boundary. In that cases you can click no. Here it is correctly highlighted the boundary, so you can click yes. Now they are misaligned. Next step is to align the tracks within this boundary. So what you have to do is this is actually different layers. First layer is your circuit, layer 5 is your drills. So if you click on this one, this is actually layer 6. It's not displayed here, so you can click on display layer 6. So this is selected. Now you can move it manually. In order to move this manually, you have to go to File, Offset, Shift manually. Now you can move this to any place. So make your circuit in center of this layer and you have to click an option here, reframe. Not over here, just above this icon you have to click reframe option. So it's reframed and the circuit is pretty good to see. Now the next step, you have to create the toolpath. Toolpath means you have to create 3 files necessary for PCB fabrication. First one is called engraving file. Engraving files will be actually for these tracks. Okay, this is our tracks. I have to click the engraving file. I have to generate the engraving file. Second one is the drills. Drills is actually this black colored points. You need a toolpath. You need a machine language file where you have to drill. Okay. So in order to make this little more simpler, I'm just going to make all the drills and pads of same shape. Okay, so I'm just clicking over here. I'm going to verify this one. Edit all identical path option is, pads option is there. You can edit this pad alone, or all identical paths could be edited together. So this 4 path is actually having a drill size of 1.2 mm. Okay, let me make it 1 mm, or let it be 1.2. We will create 2 drill files. So this is 1.2 mm, and let me make all other pads of say 1 mm. So edit all identical paths. So only 2 paths are identified as identical. So let me make the drill size as say 0.8. Okay, so these two are of 0.8 now. I will change this one also. You can, there is another option to copy shape from another pad. So you can, now you can see that another icon is available. You can click over here. So this shape will be copied to this. Similarly, I am copying shape from this pad to all other pads. Copy shape from another pad. Okay, now this one also, let me make this one also a circle. So copy shape from another pad, let it be this one. Now you have only 2 types of drills. This is 1 mm, and sorry, this is 0.8 mm, and this is 1.2 mm. Okay, now let us export this as machine languages. So what you have to verify is, go to parameters, and in selected tools we are performing 3 operations. First one is engraving. So the engraving purpose is to remove the copper from the copper clad. So the depth of the copper is around 0.07 mm. So I have set it as 0.07. Okay, so that the base will be remained, only 0.07 mm depth will be engraved. That is engraving. Engraving tool, you have to select your tool here. Right now I am going to use 30-degree engraving tool. Okay, next one is, forget about hatching. Next one is cutting tool. So this is regarding the boundary. So you have to measure the depth of your PCB. So my PCB is, you have to measure it using vernier accurately. My PCB is having a depth of 1.7 mm. So if I cut at a depth of 1.7 mm, my PCB will be detached from the entire copper board. So I have to use the total depth including the copper and the base. Now here you have to use use of each drill closest greater tool without circular boring. You have to do without circular boring. If you click on this, only one tool will be selected, but in my case I have 2 drills. One is actually of 0.8 mm and other is of 1 mm. That's why I'm using this option. So here you have to select your drills. So I don't need 0.5. I'm closing that. So let me make it as 0.8. First one is 0.8 mm, 0.8 mm, and second one what I need is 1.2 mm, 1.2 mm. I can remove all other tools. I don't need any other tools. So I have removed all this. Now once again you have to select this one also, drilling depth. So my PCB is of 1.7 mm, so 1.7 mm hole will be required. That much depth is required for drilling. Now you can click OK. I have verified all the tools. Now you can create your tool files. So you have to click on this option, mill. Before that you have to do one more thing. You have to create your engraving file. You have to click on this one, this icon. This is calculate contours. Click on that. So this is actually number of successive contours. Here I have given only one. If you increase that, here more layer of engraving will be done, so that it can go much deeper. So we are doing only 0.07 mm. We can do it at a single stretch. So number of successive contours is just 1. I am going to click OK. So this is how your PCB is going to look. This will be the structure of your PCB. These points will be engraved. So this green color thing is actually your substrate. So this is the track that I need. So I'm not removing the entire PCB. There is an option to remove the complete other copper also, but it will take time. So easiest thing is to remove a single line around your tracks. That is what we are going to do. So I'm going to click the mill option now. So I need 3 types of files. First one is engraving layer. I am going to create a Gcode for this. If you click OK, you will get a Gcode. So in the Gcode, what you have to do is, at the end of the Gcode, once this operation is completed, your tool has to reach at the home origin. It should go back to the origin. For that, you have to add codes manually. The command is G00 space X00 space Y00, so that it will be back to the origin. X and Y will be 0 points, so that you can continue the work from the same origin. If the origin is shifted, you cannot work one over the other. So always you have to give this lines at the or these commands at the end of your Gcode. So this is the end of Gcode. So here I have embedded it. Now I am going to save this as, so in desktop I am going to create a new folder. So here this is my engraving file. So engrp, you can give any name. So it will be saved with the extension .text. Okay. So my engraving file is ready. Now my I can work with this Gcode. Second thing is, you need the engraving Gcode for other layers also. So after engraving, you need to attach drills. So drill, here you can see that you have two drill files. This is one for 0.8 mm. So if you click on this 0.8 mm, this actually 1, 2, 3, 4, 5, 6. You have 6 holes. Those areas will be selected. Okay. So this is 0.8 mm. Now I am going to click OK. Now I will get the Gcode where you will have the X and Y coordinates for this 0.8 mm holes. So again you have to save it as a text file. So this is my Gcode. So before saving, I am going to embed this line G00, X00, Y00. Now file, save as. Again in your desktop I have created a new folder. So this is my drill file. So this is 0.8. So I am going to name it like this, drill 0.8. Save. Now next step is again to create your next drill file. So that is 1.2 mm size drills. And I click OK. You will get the corresponding Gcode. Again save your origin. After, when this work is completed, after drilling 1.2 mm holes, it will go back to the origin. That is the relevance of this line. Now save it as. This is actually 1.2. So drill 1.2, and I have saved it like that. Now the next step is to create a file for cutting the boundary. So you have to click on mill, select cutting out. Now just click OK. So this is the boundary file. You can see that very little information will be there in this, and at the end of the G commands I am adding these lines, so that once the cutting is complete, the machine will be back to the origin. So this is my cut file. So I mean saving in the same location. Okay. So I have created all 4 text files. So that is the use of CopperCam software. Now you can start working with these text files. So one more preparation is required before starting the machine. That is called auto leveling. So you click on this particular software, auto leveling software, auto leveler. I will tell you the relevance while working with the machine. First thing is you have to select your OS. Your OS is you have to select match 3. This is the system software that you are going to use. So click on match 3, then browse for Gcode. So among all the text files that we have created, engrave file will have the maximum information, because this file is having the pad information, track information, all those things. So maximum, just if you consider the cut file, that will have the boundary information only. If you consider the drill file, that will have only some particular drill point informations. Engraving file is having most of the coverage area informations. So using the engraving file, you have to create this auto leveling file. So in order to do that, you have to select the engrave.txt file. Just create level Gcode. Click on create. No need to change anything over here. Just create level Gcode. Now once you click on that, this will be saved as a file with extension .tap. So they have added two words, two alphabets, A and L. So that is for auto leveling, and they will use the same name which we are given for the text. If you are interested, you can change it, no issues with that. So the extension will be just .tap. So click on save, that will be saved. So that process is also completed. So once you open this folder, you can see here there are 4 text files, one for engraving, one for drilling 1.2, one for drilling 0.8, and one for cutting the boundary, and this one is actually for auto leveling. Now let us see the machine and how to I will show you the software first, match 3 mill, later. So match 3 is the CNC software that we are going to use to control our PCB prototyping machine. So first step is to do auto leveling. Auto leveling is to sense some dips or irregularities in your PCB. So you have to load, you have to click file, load Gcode. So in desktop, let me open my folder. So you have to use the tab file first. So you have to select here all files. So tab file is loaded. Okay. So here you can see the animation part, how it will be working. So you have to click X0, Y0, Z0. So now you can move into the machine. So there are 2 options to control the machines. One is using this environment, and another is using a remote which is installed or connected with the machine. So let us see how to use these files and work on the machine.